Okay, so make sure you have your trig book out, open to page 55. So if you don't have that, go ahead and pause the video and get your trig book out, open to page 55. This section is on the trigonometric functions. Remember, trigonometric functions refers to those 6 functions of non-acute angles. So sine, cosine, tangent, cosecant, secant, and cotangent of non-acute angles. Okay? The 2 questions below are going to be your 2 guiding questions for this video. You need to write them down, and at the end of the video, I'm expecting you to come to class tomorrow with an answer to these questions. So, what is a reference angle, and how do you find a reference angle? And again, I am expecting you to come with an answer to both of these questions, and we're going to discuss them in your groups tomorrow. So, what is a reference angle? How do you find a reference angle? You should be thinking about those things as we are going through the notes today. So on the top of page 55 in blue, it says reference angle. And I'm just going to read that paragraph before I write anything down. It says associated with every non-quadrantal angle in standard position. Okay, so non-quadrantal means those 0, 90, 180, 270, and 360 would not be included. Is associated with every non-quadrantal angle in standard position is a positive, so that's important, acute angle called its reference angle. Okay? A reference angle for angle theta is written with a theta, and then it looks like an apostrophe, but we call that prime. So a reference angle is theta prime, which is the positive acute angle made by the terminal side of the angle theta and the x-axis. Okay, so let's write that down. Okay, so a reference angle positive acute angle, and it's made by the terminal side of theta and the x-axis. Now that's important right there. This is a common mistake, is that people try to make reference angles with the y-axis, but it's not the y-axis, it's the x-axis. Remember, a reference angle is also denoted with that theta prime. Okay? Figure 9, back in your book, figure 9 shows several angles, theta, and then in parentheses it says each is less than 1 complete counterclockwise rotation. So they're all less than 360, okay, in quadrants 1, 3, and 4 respectively. Now, why would we not need to worry about quadrant, it's 2, 3, and 4 respectively. Why would we need to not worry about quadrant 1? Well, if we're talking about acute angles, all of the angles in quadrant 1 would already be acute. All of those angles are already between 0 and 90. So if you have an angle in quadrant 1, okay, that's between 0 and 90, you don't need to worry about finding a reference angle, because those angles are already positive acute angles. Now, let's draw an angle in quadrant 2. Okay, now it said it had to be in standard position, which means that its initial ray is there, and then its terminal ray would be where it ends. Okay, so there would be my theta. And you can obviously see that that is not an acute angle. Okay, so I would need to find the reference angle if I wanted to be able to find all of the trigonometric functions. We currently right now cannot find the trigonometric functions for non-acute angles. So the reference angle is made by the terminal side of theta. This is the terminal side of theta, okay, and the x-axis, which is right here. So this angle is the reference angle. So the angle in orange, or theta prime, is the reference angle. Okay? And then you could draw an angle in quadrant 3. So, again, it's going to have its initial ray here. It's going to go around, and let's put it in quadrant 3. Okay, so that would be my theta. And I want to find the reference angle. Again, it's the terminal side, ending side, and the x-axis. Always the x-axis, not the y. So there's my reference angle. Okay? Why don't you pause the video and try to draw an angle in quadrant 4, because here we've got 2, 3. Why don't you try to pause and draw any angle in quadrant 4 and label where its reference angle would be. Okay, so remember, we're starting in standard position, which means it starts positive x-axis. And standard position means it goes in a counterclockwise. There it is. Okay, quadrant 4, so this would be my theta. So where would my reference angle be? My reference angle is the terminal ray and the x-axis, so this would be my reference angle. Okay, and this section is all about being able to find reference angles in order to use reference angles to figure out the trig functions. Okay, so hopefully you're noticing a pattern of how would I be able to calculate where the reference angles are. So find the reference angle of 218 degrees. Okay? Find the reference angle of 218 degrees. So I think the first thing that you want to do is get a general sketch. Where is 218 degrees? You kind of need to know, because look up here. Quadrants 2, 3, and 4 were all different. Okay? So where is 218 degrees? Well, I know we've got 0, 90, 180, and 270. So where would 218 be? 218, initial, terminal. It's going to be somewhere over here, past 180. So that would be my theta. And remember, from up above, I want terminal and the x-axis. So this would be theta prime. Now remember, this is 218 degrees. The orange is. Okay? What is this line right here? Well, that's 180. So how could I figure out what this purple is? Well, I could do 218 degrees minus 180 degrees, and I am going to get 38 degrees. So theta prime, or my reference angle, is 38 degrees. It's a positive acute angle, and I found it with the terminal ray and the x-axis. Okay? So each of the different quadrants have their own set of rules. So we're going to go ahead and draw a chart that has each of the rules. Okay? So okay, these are going to be theta that is between 0 and 360 degrees. If it's an angle that's greater than 0, or excuse me, less than 0 or greater than 360, we have more than one step to do. So in quadrant 1, okay, here's my drawing, quadrant 1. Here's an angle in quadrant 1. Here's theta. Okay, cool thing is in quadrant 1, it's the exact same. Because if you look, quadrant 1, you've got theta is equal to theta prime. You don't have to do anything, okay? Those are already positive acute angles that are in standard position, okay? So we're good. Quadrant 2. What would be the rule for quadrant 2? So, here's my angle, and this would be an angle, any angle in quadrant 2. There's theta. Okay, remember, your reference angle is the terminal side, so that would be right here, and the x-axis, that would be here. So there is theta. And how would I figure that out? Theta prime is going to be equal to 180 degrees, because this is 180, minus theta. Okay, if this is 180, and this is theta, ending right there, then to figure out this chunk, I would do 180 minus theta. So see, there's different rules for each of the quadrants. So let's go to quadrant 3. And we kind of already did an example of quadrant 3, I believe. Okay, so draw an angle, standard position, quadrant 3, so it's going to rotate. Let's go all the way around until we're about out of quadrant 3. There's theta. Okay, so how would I find theta prime? Remember, it's the terminal side and the x-axis. Okay, again, this is 180. This is my theta prime, or my reference angle. Okay, and remember, rotating all the way around to here represents my theta. So how would I figure out my theta prime? It's just a little bit different than the one up above. Now we're going to take theta and subtract 180 degrees. Okay. Quadrant 4 should be our last one that we're going to do. Okay, so draw an angle in standard position in quadrant 4. Looks like that. Okay, this is my theta. So again, this ray right here represents theta. That's also my terminal side. So that will make up one side of my reference angle. And my x-axis is there. Okay, now remember, this would represent 360 degrees because we will have gone all the way around, okay, the circle. So this angle here represents theta prime, or my reference angle. How would I figure out my reference angle? Well, I want this chunk here, so we would be doing 360 degrees minus theta. Okay, so there are your rules for each of the 4 quadrants. You really don't have to memorize these rules if you would just know that a reference angle is a positive, so it's got to be positive, acute angle that's made by the terminal side of theta and the x-axis. Okay, so how do you use these to figure things out? Well, let's do an example. Okay. Find the exact trigonometric. Oh, I can't spell. Try again. Trigonometric functions for 210 degrees. Okay, when I'm asking you to find exact, I am asking for like the square root of 3, those types of things. I'm not asking for decimals, so you will not be able to use a calculator to do this, okay? So, first thing I do is I go ahead and sketch. Where is 210 degrees? Initial ray, okay? I know that's 90, 180, so it's got to be in quadrant 3. I'm going to go ahead and label that as 180 degrees. There's my theta, okay? In order to do this, I'm going to have to find a reference angle because the reference angles, I'm going to know their 6 trig values, okay? So here is one part of my reference angle. Another part is there. So this is theta prime. Okay, this, oh, when I labeled this 180, I'm sorry, 210, I got ahead of myself. This is 180 degrees. Hopefully you caught that already. Okay, so I'm looking for the difference between these two. So, and if I needed to, I could look back at my rule that says you take theta minus 180, and 30 degrees is my reference angle. And hopefully 30 degrees makes you think a little bit, oh, I think I have a chart that has the sine, cosine, tangent, cosecant, secant, and cotangent of 30 degrees on it. And I'm going to use that. Now, we are not doing 30 degrees. However, the answers for these trig functions are very similar. What ends up happening is I just need to account for the fact that instead of it being 30 degrees in quadrant 1, I have 30 degrees in quadrant 3. And in the first unit, we talked about, well, where are sine, cosine, tangent, cosecant, etc., positive and negative? Well, if this was truly 30, then I would just fill out directly from my card, okay, and copy all them down. But this is in quadrant 3, so now I'm going to have to account for the fact that some of these numbers are going to be negative. So all students take. Take stands for tangent. Tangent and its reciprocal, cotangent, are the only two that are positive. So I'm just going to go ahead and fill in negatives for the other 4. And now all you need to do is literally reference your chart, okay, 30 degrees, because that's our reference angle, and fill in directly from your chart. That's why it's important that eventually you will have that memorized. So the sine of 30 degrees is 1/2. Now we're in the negative, so it's negative 1/2. Okay, the cosecant then is -2. Cosine is negative square root of 3/2. Secant then is -2 square roots of 3/3. Remember, this is directly coming off of that chart. Square root of 3/3. And then square root of 3. And you would be done. Okay? So, exact trig functions, if it's not one of those angles, then I found my reference angle of 30. Then I just looked directly off my chart to figure out these numbers, but I had to account for the fact of what quadrant the angle was actually in. Okay? Now, what if theta is less than 0 or greater than 360? So for example, what happens if you were asked to find the cosine of -240 degrees? Okay, this one just has an extra step. In the first unit, we talked about coterminal angles. So the first thing you would need to do is find a coterminal angle that is between 0 and 360. Okay? And then you find the reference angle of your coterminal angle. So we would use rules to find reference angle of the coterminal angle. Okay, so here, negative 240. The first thing I have to do is find a coterminal angle. So step 1, I'm going to do negative 240 plus 360. Okay, remember, to find coterminal angles, you're just either adding or subtracting 360. And I believe when you do that, you get 120 degrees, which means this angle, okay, is really negative 240 would be here. That would be my original theta, negative 240. Now it's coterminal angle. Remember, that ends in the same spot, but it's a positive angle. Would be this direction. That would be 120 degrees. So that still doesn't get me what I want. Now I'm actually looking for terminal and x-axis. This would be my reference angle. Okay, so how do I figure that out? You want to know the difference here. 180 minus 120. So the reference I am looking for is 60 degrees. So I'm really looking for the cosine of 60 degrees. However, I'm going to account for the fact that it is in, okay, quadrant 2, so all students. So I know that the cosine of 60 is 1/2. However, the cosine of negative 240 degrees is not 1/2 because we're not 60 degrees over here. It's 60 degrees in here. All students, I know this is negative 1/2. Okay? All right, so at this time, I'm going to go back to those original 2 questions. Again, I'm expecting at the end of your notes tomorrow when I check to see these 2 questions written with an answer. So, what is a reference angle? Okay, and how do you find a reference angle? You need to come with an answer and be prepared to discuss those answers in our groups tomorrow.